Okay, so the um, chapter 5 is all about sequences and series. I'm going to tell you that section A is extremely easy. Okay, it's just your basic terminology. If I had to say anything about this chapter, it's the notation that's difficult. Once you totally start to understand the notation, the math is not terrible. So this whole entire chapter is all about patterns. So being able to recognize a pattern, being able to describe the pattern, and to continue the pattern. So this definition, a number sequence is just an ordered list of numbers defined by a rule, and the numbers in the sequence are called the terms. So consider the picture, and a lot of times you're going to see a picture and you've got to make a relationship between the picture, finding a pattern, and making an equation. So we'll get to that point. Right now, we just want you to be able to recognize the first row has 3 bricks, the second row has 4, third row 5, and so forth. So listing this out can help you find the pattern, is understanding how does the picture correspond to the numerical. All right, lots of words here. A sequence is just a pattern of numbers. We list the terms with a comma, using correct words to describe. For example, the sequence starts at 3 and increases by 1. The explicit formula is an equation to be able to find the sequence no matter where you're at. It gives the nth term. We could also call it the f of n term, any of this. You can create a graph, but be very careful. When we're talking about the first term, the second term, the third, there's nothing in between here, so you wouldn't connect the dots. They're individual dots that are not connected. Okay, so I want everybody to take a minute, look at these numbers, describe the sequence, and write down the next 2 terms. I'd recommend you pause the video and do that yourself. Then when you're done, turn it back on and see how you do. I notice these are going up. We're adding 3 specifically. So the first term is 14. Then add 3 to get the next term. All right, so the next 2 terms, 23 plus 3 is 26. 26 plus 3 is 29. All right, your general term is just, this is where I'm saying the terminology gets a little bit funny. U sub n is the nth term. And you'll see this will make a little better sense in letter B. I'm going to do B also. So the first, U sub 1 is the first term. U sub 2 is the second term, and so forth. It just keeps going, okay? What's really important, this right here said n belongs to the positive integers. 1, 2, 3, 4, 5, and so forth. All right, and then we're going to use this and find equations in section B. That's all of section A. Look for patterns, describe the patterns, and find numbers in the sequence. I'm going to just kind of point this out. The Fibonacci sequence is something you see all the time that you don't even realize. It has to do with the golden ratio. It actually has to do with pine cone patterns, tree patterns, seashell patterns. And it's just adding the previous two terms to get the next one. So we start with 1 and then go to 1. 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 3 is 5. I've actually had people do IAs on this where they have done many different topics, but it's kind of interesting little sequence. Okay, so letter B is all about a specific type of sequence, and that's an arithmetic sequence. Now, when you see this word, typically you think of arithmetic. Arithmetic is a noun. Arithmetic is an adjective describing the type of sequence. So how we pronounce it actually describes the word. An arithmetic sequence just means we add a number to get the next term. We add the same number every time to get the next number. The number that we add each time is the common difference. Now, this notation here just means, here, let's take this one here. I'm going to write this down here. If a sequence is arithmetic, what this says is I take some term anywhere here, let's just say 8, minus the term that comes before it. 8 minus 5 is 3. That's why 3 is called the common difference, because I'm going to add 3 each time. But to find that number, we'd always take one number and subtract the previous number to find the difference is 3. But it's arithmetic because what we're doing every time, plus 3, plus 3, plus 3, plus 3. You find that number, though, by taking one number and subtracting the previous. And then you know your number every time. Okay, so your general term. I'm just going to say this right here is what's important. An arithmetic sequence with first term u sub 1. That's how you read that. U sub 1 is the first term. Common difference, D. We find the general difference or general term by this equation. U sub n, the nth term, equals u sub 1 plus n minus 1 times D. This formula is in your formula booklet. You have to recognize when to use it, though. All right. Just going to make a little bit of room. So part A says, show the sequence is arithmetic. What makes it arithmetic? The difference between each set of numbers is the same. 9 minus 2 is 7. 16 minus 9 is 7. I'm going to take each set of numbers and show that their common difference is the same. Therefore, the common difference equals 7, and it's arithmetic. Okay. The general formula. What we need to know for the general formula is u sub 1 which is the first term, is 2. The common difference, what are we adding each time, is 7. Take the equation and just substitute. And you can simplify this. I think the book probably does. So we can distribute the 7 and then add like terms. Oh, what am I doing? See, if you were in class, you could have said, what the heck are you doing? And that's our general sequence. So we can determine any number of sequence in this pattern. So here, what's the 100th term? I just take and find u sub 100. So plug 100 in for n. And solve. Okay, so if we know that term, that goes in place of n. Here we were looking for u sub 100. The question is 828 and a term, a final term? That means this number here. So can I get 828 from this formula? Well, if we add 5, divide by 7, I need n to be a whole number. It has to be a positive integer. 119 equals n. So yes, we would say 828 is u sub 119. So this has to be a counting number that you can actually use. All right. Finally, let's see what number I need. 2341. Is this a number that makes n into a whole number? So add 5. Divide by 7, and I get 335 and 1/7. This fraction or decimal, whatever you'd have, would tell us that it is not a whole number, therefore, no. It is not a part of the sequence because this is not an integer. All right. That was kind of a lot. There's a whole bunch of information, but this is a lot of what you need to know. All right. Example 3 is not tough, but it helps for you to kind of make sense of it. So to me, what helps, 3k plus 1 is my first number. K is my second number. -3 is my third number of an arithmetic sequence. So does it make sense that how do I find D? I find D by taking my second number and subtracting my first number. Or how else could I find D? I could take my third number and subtract my second number. Both of these would find D, but now I have two equations that both equal D, which means they equal each other. see they both equal D. That means they have to equal each other. So I'm going to distribute my negative. Combine like terms. I need to get K on the same side. I'm going to add 2K because that makes my K positive. Add 3. I'm already getting my answer. Ugh. Doing too much in my head. K equals 2. Now, what I would also do just to show that it's arithmetic, if K is 2, does that make this sequence work? So 2 in for K, 3 times 2 is 6 plus 1 is 7. K is 2 and negative 3. So what do I do to 7 to get 2? Well, 2 minus 7 is negative 5. Negative 3 minus 2, negative 5. So that does make it arithmetic where I'm adding negative 5 every time. So this I did just to prove that this was true. This one's a little bit sneakier. All right, so first of all, my general formula is u sub n equals u sub m plus n minus 1d. All right. Now, u sub 1 is the first term, u sub 2 is the second, u sub 3 is the eighth. This says u sub 3 is 8. All right, doesn't make sense that I'd add whatever the difference is 2 times to u sub 1 to get to 8. Do you see what I'm saying? So then what we can say, I'm literally just going to write that out. I'm going to take u sub 1 plus 2d, and I get 8. All right, what about this one? I'm going to start at u sub 1. How many differences would I add to get to 8? That would be 7d, and I get negative 17. So if it helps to actually write out u sub 1, u sub 2, u sub 3, u sub 4, to write all those out, it might be helpful. Now, do you notice I now have 2 equations with 2 of the same variables? Think back to Algebra 2, and we'd want to solve this with systems of equations, and I would just use elimination. So what I'm going to do, I'm going to multiply through my top equation by negative 1. Negative u sub 1 minus 2d equals negative 8. And I'm going to add my like terms. So my u sub 1 cancels. And I get 5d equals negative 25. So my d is negative 5. All right. If we're looking for our u sub n, there's 2 things we got to know. U sub 1 and d. Well, we just found d is negative 5. Be very careful that you put negative 5 in parentheses, otherwise it looks like minus 5. Well, how could I find u sub 1? First of all, you could use your pattern here. If I'm subtracting each 5 going to the right, I could add 5 to go to the left. If that doesn't make sense, I would just use an equation. U sub 1 plus 2 times negative 5 equals 8. So u sub 1 minus 10 equals 8, or u sub 1 equals 18. Either way, 18 is the answer for u sub 1. And this is my general term. They might distribute out the -5 and add the 18, kind of condensing it down. But either way is fine with me. All right, last two questions. So it says insert four numbers between 3. 1, 2, 3, 4. Four numbers between 3 and 12. So to me, what really helps is to actually see those numbers as blanks. So I'm going to start with 3. I'm going to add 1, 2, 3, 4, 5. So if I think of my u sub n formula, it's u sub 1 plus n minus 1 d. So let's consider this to be 1, u sub 1, u sub 2, u sub 3, u sub 4, u sub 5. This is my 6th term. 12 is my nth term, my 6th term. 3 is my first term. N is 6. And I use this to solve for D. So I plug in all that I know. So D equals 1 point, in this case, decimals I think are actually easier. I'm going to say 1.8. And then, so when I add it, I'm going to get 4.8, 6.6, 8.4, 10.2, and 12. So if you did it right, when you add your D to the last one, you should get that number. And so those are my 4 missing numbers that I needed to fill in. All right. Last one is a word problem. This is going to be more like what you guys will see. I'm going to tell you the bell's going to ring on me pretty soon, so I'm going to try and do as much as I can. Then just use the book to finish out if the bell rings. Okay. So he's a cartoonist. His comic strips just been bought. He sends them his 28 strips that he has so far. So we're going to call that the first week, u sub 1. Week 1. In the second week, each week after, he sends 3 more. 28 plus 3 is 31, which is week 2. U sub 3 is 28 plus 3 plus 3, or 31 plus 3 is 34, week 3. Each time, plus 3, plus 3, plus 3. U sub 4, I'm just going to say 34 plus 3 is 37, and that's week 4. So that was part A. Find the total number after 4 weeks. All right. So part B kind of is annoying. 31 minus 28 equals 3. 34 minus 31 equals 3. 37 minus 34 equals 3. Therefore, my common difference is 3. All right, so then we're going to make our arithmetic sequence. U sub n equals u sub 1 plus n minus 1 d. U sub n equals my first term, 28 plus n minus 1 times 3. Let's go ahead and simplify. It'll be easier to do. Because now, for letter C, I want to find u sub 15. So I can just plug 15 in for n. So far he has sent 70 comic strips. Okay, so when does he actually send his 120th strip? So that's using this formula. When does U sub n? What is n when it's 120? Okay, so 120 equals 3n plus 25. So 3n subtract 25, 95 equals 3n divided by 3, and equals 31 2/3, just in time. Now, he hasn't sent it until I actually hit my next week, so we say the 32nd week, because after week 31, he hasn't sent that third one yet. So the 32nd week would be our final answer.